For my CA teaching sample, I wanted to go over the axioms of probability. And these axioms of probability are the foundations of probability theory, and they help us compute probabilities of different events that we care about. So first, we'll start by kind of going through each axiom separately and giving an example for how each of them works. So for the first axiom, axiom one, this states that the probability for any event, so let's say for any event A, the probability of that event is greater than or equal to 0, or in other words, it's non-negative. So an example of this might be, let's say we're flipping a coin and maybe want to determine what's the probability of getting heads from one coin flip. So we know for one coin flip, the sample space or number of total possible outcomes is 2, right? Because we can get one heads or one tails. And the event we care about is getting a heads. And if we want to compute this probability, well, the probability of, I'm calling that A. The probability of our event A is equal to the number of outcomes of our event of A all over number of total outcomes. And in this case, probability of our A is just getting a heads. So we know that there's one opportunity for us to get a heads all over the 2 total possible outcomes because we can get a heads or tails. So our probability is 1/2, which is also equal to a 50% likelihood. Okay, awesome. So for axiom 2 now, this one states that the probability, I'll just write this in shorthand notation. So the probability of the sample space, so we have S is equal to the sample space, or the space of total possible outcomes, then the probability of S is equal to 1. So if we're looking back at our example with heads and tails, we know that S is equal to heads or tails for one possible flip. And if we want to compute the probability of that, well, we can just use the equation that we determined up here for computing the probability of any given event and say that then the probability of our event S occurring is equal to the number of outcomes of S, which is 2 because we have heads or tails. And we know that the total possible outcomes is also 2. So in this case, we get that the probability of S equals 2/2, which we know is just 1. So that's a demonstration of how axiom 2 works for the coin flipping problem. And lastly, our third axiom states that the probability, if we have separate events or unique events, A1, A2, and so on, and they are disjoint, meaning that these events cannot occur at the same time, then we have that the following holds. Then we have that the probability of all of these things occurring in union is equal to the sum of their individual probabilities. So I'll give a kind of a quick example of what it means to be disjoint. So we have this big rectangle here, which represents our sample space or space for total possible outcomes. And we have, let's just say, 2 events, A1 and A2. And this is an example of 2 events being disjoint because we see from this diagram that they cannot occur at the same time. And as an example of this axiom, let's say we are rolling a die. So we know that the total possible outcomes are 1, 2, 3, 4, 5, and 6. And if I want to know if we have an event A1, which represents rolling a 1, and event A2, which represents rolling A2, then I know what's the probability of the union of those 2 events. Well, we know that rolling a 1 and rolling a 2 cannot occur at the same time because it's a die and you can only roll one face. So if we wanted to compute this, since these 2 events are disjoint, then we can just use the result from our axiom. And so this would become the sum of the individual probabilities, which is equal to 1/6, right? Because we can get a 1 with 1/6 and a 2 with 1/6. Sorry. And that resulting probability is 2/6. And so that's just an example of how this third axiom is played out in practice. Thank you.